In this video, we're gonna talk about stages of the activity life cycle. So what is activity? Okay, we've been building activities throughout this series. For example, this if you look at this, our class main activity is it extends component activity. So this is an activity. Okay, there's also another class. Extending that class makes your class an activity. That's called just activity. So anyway, the goal of this video is to introduce you to the different stages of the activity. So you have an activity in your app, and we want to know what stages of what phases it goes through when it's created until it's destroyed. But first, we want to know about some facts about activities in general. So I have some notes that I want to read out. I'm going to read out aloud. Every activity has what is known as a life cycle. The activity life cycle consists of the different states that an activity can go through, from when the activity first initializes to its destruction, at which time the operating system reclaims its memory. Typically, the entry point of a program is the main method. I can give for this I can give you an example. For example, all the Kotlin Kotlin programs we've been building starts with main function, but Android apps begin with the onCreate method. If you haven't noticed it, I believe, yep, here it is. Every activity begins with onCreate method. As the user starts your app, navigates between activities, navigates inside and outside of your app, the activity changes state. We're gonna go through all the available state your app can go through in a bit. An Android app can have multiple activities. However, it is recommended to have a single activity, and so far that is what we've been doing in this course, right? Often you want to change some behavior or run some code when the activity lifecycle state changes. Therefore, the activity class itself and any subclasses of activity, such as component activity, implements a set of lifecycle callback methods. Android invokes these callbacks when the activity moves from one state to another, and you can override those methods in your own activities to perform tasks in response to those lifecycle state changes. We don't control when the app activity changes lifecycle, but the system, right? The system changes the state of the our activity, but we can override what happens when the activity reaches that state. So for example, when you click the icon of our app, it reaches a state, creating state. So when it reaches that creating state, this onCreate methods called, but we can override those methods in our own app, just like we're doing here. So we tell the system what happens when onCreate when the application is created, we tell it to set content. We basically tell it to create a UI, right? Then let me show you all the available activities. Okay, so the activity first initializes, right? When we click it, it's then created, and it starts, and it resumes. We're gonna look at how this looks like in our app. So these are the phases an activity can go through. Also, these are the methods. So when our app is initialized, onCreate method is called. To create, we call the onStart. When the application starts, onResume is called, and when the application loses focus, onMethod is called, and then onStop, onDestroy. All these methods are available for the activity. The activity can go through all these phases. We're gonna look at visually with an example using Android Studio. I am in the main branch. Let me quickly go to the starter branch. In order to really understand the activity phases, we're gonna use logging functionality of the Android Studio. We use log. I'm gonna create a const called the main activity. I'll be back after creating all this code. Okay, so I have created the logging function. First, I have created this tag variable that's the main activity, and then so when you're gonna notice that when we override the onCreate method of this component activity, we also call super onCreate passing saved instant state. We're gonna look at why we're doing that. After a while, I am also like overriding all the states available to this activity, and also calling the super. We need to do this every time we override it, and then I'm logging some messages to the when you log some messages, you can use the logcat tab on your Android Studio to see the messages. Let's look at all the available way you can all the available kind of messages. Okay, log method looks like this. The first parameter accepts a string that's used for tag, and then some message that's a string. The log class has all these like methods, d, v, d, I, w, e. V is for verbose messages, D for debugging messages, and I is for informational messages, W is for warning, E for error messages. If you use these methods, the message is gonna appear in a color-coded format. So the tag I have defined for this is called main activity. So this is how you filter all the log messages. You mentioned the tag used for you used without this, you get all these you know messages. Okay, so you're gonna notice that when I run the app, onCreate method is called, and onResume method is also called. So these two methods were called when we launched the app. When the onResume is called, the app becomes visible. Okay, so let's go back to our notes. The onCreate method is where you should do any one-time initialization for your activity. For example, in onCreate, you call setContent, which specifies the activity's UI layout. The onCreate method lifecycle method is called once, just after the activity initializes, when the operating system creates a new activity object in memory. After onCreate executes, the activity is considered created. When you override the onCreate method, you must call the superclass implementation to complete the creation of the activity. So within it, you must immediately call super onCreate. The same is true for other lifecycle callback methods. Okay, so that's pretty much it. From the notes, we now know why we are calling the super on create this method, but still we don't know why we are passing this. So look what happens if we go back to home screen. So when we go exited the app, onPause called, and onStop method is called. So when you initially launch the app, the object, the activity itself is stored in the memory. When onResume is called, the activity becomes visible. When onPause is called, your app loses focus, so you cannot interact with your app. We will see how this how we can how this works in a bit. onPause, when onStop is called, our app isn't visible anymore. So our app is in onStop stage. So what happens if we relaunch it? Okay, so the onRestart method is called, and onResume is called. We're gonna look at onRestart later, but when the onResume method is run, our app becomes visible. Okay, my bad. I didn't override the onStart method. So when you initially launch the app, if onCreate method is called, and then onStart method is called, and then onResume method is called. So let's we know the app becomes visible when the onResume is called. Let's look at onStart. What happens? Okay, the onStart lifecycle method is called just after onCreate. After onStart runs, your activity is visible on the screen, unlike onCreate, which is called only once to to initialize your activity. OnStart can be called by the system many times in the lifecycle of your activity. Note that onStart is paired with the corresponding onStop lifecycle method if the user starts your app and then returns to the device's home screen. The activity is stopped and is no longer visible on screen. Okay, so there is another thing. Notice what happens when we close the app. When we exit the app, instead of removing the app from the activity stack, I mean, we have two methods such as onCreate, the corresponding method to stop the app is called onDestroy. Instead of calling the onDestroy when we exit the app, the app calls onPause and onStop. So why is this? Well, the system thinks that the user probably wants to go back to the app, so it keeps the app around in activity stacks. For example, if you have multiple apps open, have have other apps open, these apps are stored in something called activity stack. Whenever the system runs out of memory, or whenever the app is in the background for way too long, the system exits the app. It uses the destroy method to exit the app, or user can manually exit the app by like that. The process just ends. Or they could go to the app's settings and click on force stop. Okay, so let's see the behavior of apps when we change the objects or variables of the app. When we click the image of the foods desserts, the variables are changed. For example, these variables, and I exit the app, and when that happens, onStop method is called, so our app is not visible. But when we click the app again, as you can see, the variables and the objects all are retained. So this is what it does. On a resume, right, the onStart initializes the objects and all those things, and on resume uses the same object. Let's look at what happens if we click the share button. Okay, as you can see, onPause method is called. if you remember, unstop method makes our vis makes our app what's that, invisible. The interface stops showing. So but the only unpass, what is it, unpass method is called. So when the unpass method is called, the activity loses focus, so we cannot interact with the activity anymore. We can go back to the activity if we click outside of that dialog thingy, and resume is called, so we can the app the activity as all our focus, and we can interact with it. There are times when our activity can lose focus. So some, for example, like this, when system pop-ups like this open, or some external application interrupts your activity, for example phone calls. So you kind of like handle those sort of situation by passing in some codes you want to run when that stage occurs, when your app reaches that state. For example, you might want to stop doing some processes, such as downloading something when you receive a call or something. Okay, so I want to show you something. Okay, what happens when we rotate the phone? Look what happened. Our values are reset, and if you check our log, our app actually called the on destroy, and we called create and start and resume. So what happened? Why did it our app didn't destroy when we clicked the home button, but it destroyed when all we did was rotate our phone. So why was that? Okay, so these are called configuration changes. So a configuration changes occurs when the state of the device changes so radically that the easiest way for the system to resolve the change is to completely shut down and rebuild the activity. For example, if the user changes the device language, the whole layout might need to change to accommodate different text directions and string lengths. If the user plugs the device into a dock or adds a physical keyboard, the app layout may need to take advantage of a different display size or layout. And if the device orientation changes, if the device is rotated from portrait to landscape or back the other way, the layout might need to change to fit the new orientation. Okay, so basically what happened is that the system thought to accommodate all the available space in the landscape, we need to actually run all the composable once again. So it's just so the easiest way for it to recompose everything from start to finish is just by calling the onCreate method again. So you need to be aware of when your apps can go a configuration change. For example, the one such example is this, rotating our phone. So in the past we used remember and state to save our variables across recompositions, but what if we wanted to save our variables across configuration changes? We use remember savable for that. Okay, so I have replaced all the remember statements with remember savable. Let's see what happens when I rotate the phone. Right, now the variables are remembered across configuration changes. Anyway, that's pretty much it for the activity lifecycle. In the next part, I'm going to show you how you can clone the repositories from GitHub, and I'll see you again.